In our last video, we talked about how to solve linear systems by graphing, and in this video, we're going to talk about how to solve linear systems with two variables using other techniques. Substitution is one of the other techniques. So if we have a linear system, that means we have two straight lines, and we're considering both of these lines at the same time. So off to the right, I've written some steps to help us get through the substitution process. The first step is to solve one of the equations for one of its variables. That means you either want to rearrange everything to say x equals something or y equals. The second step is to substitute the expression for the variable found in the first step into the other equation. Once you do that, Step 3 says you can find the value of one variable by solving the equation that you form in Step 2. So once you find either x or y, you should be able to substitute that numerical value back into one of the equations and get the value of that second variable. Let's see how that'll work. In our first line, 2x plus 4y equals negative 6. So neither x nor y has been solved for. In the second line, x equals 2y minus 5. So here we have x isolated already. So that means if x is worth 2y minus 5, we can take this expression and substitute it for x in the first equation. So we have a new equation to write. Instead of 2x, we're writing 2 times the new value of x. That's 2y minus 5. Then we'll add 4y equals negative 6. So we'll distribute 2. 4y minus 10 plus 4y equals negative 6. Collecting our like terms, I have 8y minus 10 equals negative 6. So I only have one variable term. That means positive 10 will be added to both sides to eliminate it from one side and collect it on the other. 8y now equals 4. So when I divide each side by 8, I'm going to have a y value of 1/2. So what we have just determined is that these two lines will intersect, and the y value of their intersection is 1/2. So I know I'm going to have one solution, and it's going to be at the ordered pair such that 1/2 is the y value. So we need to figure out what the x value is. So this is where we're going to take this value for y and use 1/2 for y in either one of the original equations. So it looks like the second equation is easier to use. X equals 2y minus 5. And we know that the y value is 1/2. X equals 2 times 1/2 minus 5. Well, 2 times 1/2 reduces, leaving x equals 1 minus 5. So the x value is negative 4. So negative 4 goes up here in the ordered pair. So these two lines should be intersecting lines at this one point, negative 4, 1/2. And that's how substitution works. Let's try another example. Our first line is x thirds plus y equals 4 thirds. Well, that looks a little awkward with x thirds. So you might want to rewrite that as 1/3 x. So just remember that it's really 1/3 x. The second equation, negative x plus 2y equals 11. So it doesn't look like x has been solved for, y has not been solved for, so we'll have to do a little rearranging of our own. So since that first linear equation has a positive y, it would be easy to solve that equation for y. So to rewrite that, all I would have to do is subtract 1/3 x from each side to get y equals negative 1/3 x plus 4/3. Since I have a new expression for y, I can take this expression and substitute it for y in that second equation. That gives us negative x plus 2 times the new value of y. That's a minus 1/3 x plus 4/3. That is set equal to 11. So I'm going to distribute positive 2 to each term in this quantity. Negative x minus 2/3 x and plus 8/3 equals 11. Now you'll notice we have some fractions, but we've learned in previous lessons how to eliminate fractions from an equation. And that technique is involving the lowest common denominator. Since both of these denominators are 3, 3 must be the lowest common denominator. So we're going to multiply every term in our equation by 3. 3 times the negative x minus 3 times 2/3 x plus 3 times 8/3 equals 3 times 11. This is the multiplication property of equality. So when I multiply 3 times negative x, I'll have negative 3x. And then notice how these 3's are reduced, and I have negative 2 times x. So that's minus 2x. These 3's are reducing, so I just am left with positive 8. And last equals 3 times 11, or 33. So when I collect these like terms, I'll have minus 5x plus 8 equals 33. And now all we have to do is isolate x. Subtraction of 8 leaves us negative 5x equals positive 25. Our final step is to divide each side of this equation by negative 5. So the x value is now equal to negative 5. Since we were able to solve for one of the variables, once again, we're going to have one solution to this system. And the solution involves an ordered pair. Since we just found x, then the x value of the ordered pair is negative 5. To find the y value, we use x value of negative 5 and substitute that into either one of the original equations. So you're probably thinking the second equation looks a little bit easier to substitute. So that's the one we'll use. Negative times the x value plus 2 times y equals 11. So right off the bat, we have something difficult. Negative x means negative multiplied by the x value. And our x value happens to be another negative number. So negative times negative gives us 5 plus 2y equals 11. Subtracting 5 from both sides of our equation, we end up with 2y equals 6. And now division of 2 means y is equal to 3. So now we have found the corresponding y value, and we can fill the ordered pair in. So we know that this system of linear equations has one solution, and that is the point negative 5, 3.